So what do you want to do with this one? Logan, here we go. Redeem yourself from not knowing property 5. Okay. Somebody did that first period, and I'm like, why? Okay, where are you going to use it though? But you said VT was equal to VT. You didn't say that VT was equal to an opposite side. You don't need that step in there. You can just tell me, ready? VT is congruent to what? X or WX. And VT is also congruent to what? Y, Z. You don't need to say they're equal to each other, though. Based on the work we did yesterday, what do you think I'm going to have you write in for a reason here? Kevin, go. It needs to be a what first, though? Parallelogram implies opposite sides congruent. Everybody good there? So, okay, you used something new there. Nice job. And now I need something old. All right, I need something old here to help out. Aaron, how are you going to put all this together here? Look, WX and YZ are both equal to VT. So what do I know about each of them, Aaron? WX congruent to YZ, little thing we like to call substitution. It really doesn't get more basic for that other than this here for your parallelogram proofs anyway. Questions? Anything you want to ask before we proceed to the middle school level? This one's a lot of work. All right, but it's not too advanced here. It's going to be a lot of work to get the proof statement accomplished, but it won't be too bad. Ready to go? Let's rock it. Here we go. Come on. First thing, I don't know if this was in the homework last night or not. Sometimes you'll see that symbol. That just means it's a parallelogram. I would appreciate it if you never, ever use that symbol on your own, because I don't know how much more lazier it could get. Okay? So please do not use that symbol on your own. I guess you can use it on homework and stuff, but don't show me on a test or quiz. Write 11 ogram or write out parallelogram. Yeah. Oh, yeah. Hey, we're proving triangles congruent, huh? Those two outside ones. Everybody good? We're proving those two outside ones because that's not what I want highlighted here. Everyone good? You're proving those two outside ones. Here's what I want highlighted. This one right here, ABCD, is a parallelogram, so all 5 properties apply. We can use them if we need them, those properties, which I think we're going to use a couple of them because it wouldn't have told us it was a parallelogram. All right, and also, look at this one. DF, the long segment here, is congruent to EB. Yes, sir. Here we go. So my first question to you guys, if we're going to prove the triangle's congruent, did I provide you with a full pair of sides or angles in the givens? Right now, look at my diagram. Are any full sides or angles marked in those 2 triangles? No. So you have to come up with all 3 on your own. On your own, you have to come up with all 3. Where's the first one going to be? Here we go. Properties of a parallelogram would probably help. Naomi, what do you got back there? Say that again. All right, full pair of sides. I like it. DA, congruent to CB. She just gave us a full pair of sides. 1 down, 2 to go. What's your reason going to be back there, Naomi? Perfect. Got a full pair of sides down. Nice job, Naomi. Got a full pair of sides. Natalie? Okay, she's going to roll with here. DC congruent to AB. Now, that's not a full pair of sides, but can it lead me to a full pair of sides? Yes, by doing what? Subtraction, an oldie but a goodie, yes. So right here in step 2, I'm just going to write DC congruent to AB, because it's got the same reason. All right, I don't need to show off and write it again. Then I'm going to do what to get to the sides in the triangle? Do what here to my given and what Natalie just gave me? Subtract them. Okay, so I'm going to say, let's see, what do I have? DF minus DC is equal to EB minus AB. Yep. Subtraction. And nothing, I don't care that we're in unit 6. I don't care that we're in mid-December already. What's always after subtraction or addition here? Substitution. To say that EA is congruent to CF. Yep. Geez, I got a lot of hash marks, huh? Two pair down, one to go. One to go. Now look, you have two sides, right? So out of the 5 methods, it can only possibly be what? Side, 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 or side, angle, side. It's got to be one of those two. Natalie, on fire here, huh? Okay, hold on. Don't say any more, please. Do not say any more. Here's what you just said. Opposite angles in a parallelogram are congruent. Yes. Are those angles in my triangles? Could we, based on something we've been doing all year, can we get them in the triangles? Yes. Got a thought there, number 3? Sorry, too soon? Too soon? Too soon, Izzy? Go ahead. Supplements of congruent angles are congruent. Okay, because those are supplementary. All right, whoa, 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 whoa. Everyone's got good ideas. We just got to write it properly. So the first thing I need to tell you is those angles are congruent. So I have angle. What's that angle there? Scrolling. I just got to write smaller. DAB. Congruent to B, what is that? CD? Who gave me this one? Is that Natalie? What do you got? Why? Yep. And then Izzy, you said supplements of congruent angles, right? But I'm not ready for that in this step. Why not? Anybody remember before you can use that? You got to tell me what, Michael? You got to tell me what pairs are supplementary first. All right, tell me what pairs are supplementary. So, oh boy. DAB and DAE. And what's the other pair up there? BCD and BCF. What have we been saying all year long? Why those are supplementary? Linear pairs are supplementary. Yep. That's why I enjoy this course so much, is because, hey, linear pairs are supplementary is something we talked about in Unit 2, and it's not going away because we're done with Unit 2. Now we can go to Izzy's point, which is saying those angles are congruent by supplements of congruent angles. Are congruent. And then I'm going to need somebody to tell me the method why those triangles are congruent. Angle DAE congruent to BCF. Supplements of congruent angles are congruent. And then finish it off. What reason now are the triangles congruent? 12. Side angle side, yep. Nice. A lot of work. Not too bad. Not too bad, but a lot of work, considering we were given no sides or angles at the beginning. Everyone good here? Yes, Aaron.
Could you have also said that DF and EB are parallel, and then alternate exterior angles are congruent to get EAD and FCD congruent?
EAD. So the angles we just
The
did.
angles we just did. Could you have done those two lines are parallel, and then?
Where's your transversal?
Oh shoot.
They don't have a transversal in common, right?
I was thinking that they were inside.
Okay. Yeah, they don't have a transversal in common, so. All good? All right, you ready to go honors level? The final step today. And it is not number 3. If we have time, that's the one you're going to do on your own. The big dog is number 4. First thing I heard first period. Oh, look at that diagram. It's making my eyes hurt. Yeah, well, you make my ears hurt with your voice, all right? Got to prove the 2 outside ones congruent. Whole thing's a parallelogram. Now, I will admit, the start of this is very easy. Did I give you any sides or angles? Did I provide you any sides or angles congruent? Not you. No, I did not. You're going to provide them for me, all 3. The first 2 are very easy. First 2 should be very easy. The third one, we're going to have a struggle with. All right, so anybody get me some quick sides or angles right now? Kevin, go. AE and E. Oh, I don't want to go. Those aren't sides, though, I need. Right? I'm talking full sides in these 2 triangles that I'm trying to prove congruent. Or can you get me sides or angles if you know? Remember, this thing's a parallelogram. Properties. Jacob. Are those full sides, though? Right? Okay, I don't know if you guys are thinking ahead, but I need full sides or full angles right now in my triangles. That's what I'm looking for. Full angles or full sides. Marlise, go. Okay, guys, look. I'll mark it, but EB is not part of that triangle, right? See what I mean? So that's not a pair of full sides. Good? Everyone good here? Don't do this to me. Charlotte, don't do this to me. Angle A and angle C are congruent. There we go. There's a full pair of angles. Angle A congruent to angle C. Why? There you go. Maya, don't screw this up. Come on. DA is congruent to CB. Pair of full sides. Yeah. Back yourself up, Maya.
Oh, in a parallelogram, opposite sides are congruent.
I thought the first 2 were going to come quicker, but it happens. It happens. And you guys that were telling me the other stuff, we're actually going to use that. I don't know if you know that or not, but we're actually going to use that stuff. All right, we got 2 down. 1 more to go. And this is why this proof is so tough. We haven't used what in the givens yet? The whole midpoint. All right, now watch. Just watch here, because I know you're going to give me this. Yes, I get it. These 2 are congruent by definition of a midpoint, and these 2 are congruent by definition of a midpoint. But it still does not get me AE congruent to FC. All right, that still doesn't get me there by saying definition of a midpoint. Everyone, am I showing you that? All right, are we good there? These 2 are equal, and separately, those 2 are equal. But these 2, not to each other. Yet, anyway. So this is where we dig deep. It's been a while. That's all I'm going to say. It's been a while where we've needed this. What's up, Kevin? AB is congruent to DC. How? He's right. His start was right, that AB, and I'm going to write this in right now, AB is indeed congruent to DC. Yeah. You're right. We're going to use that, though. We're going to use that. Oh, boy. Yes, Jacob?
Say that A is half of AB, FC is half of DC, and then you do halves of equal quantities are equal.
Welcome back to halves of equal quantities. Look at this stud. Yeah, good job. All right, ready? You want to take half of? Take half of what side first? AB. All right, here you go. Half of AB. Well, if you took half of AB, you'd get either AE or EB. But I'm only concerned with one of them. Which segment of the two am I concerned with? The side of the triangle, AE. And then what other side are you going to take half of? DC. And if you took half of DC, that could be segment FC or segment FD, but which one am I concerned with right now in this proof? FC, yep. And I don't think you guys do. I want to clear this up. Why I needed to write that step right there? Whatever I take half of needs to be equal. Halves of. Okay, so whatever you take half of needs to be equal as well. All right, what's the reason going to be here? It's not halves of equal quantities. What up here said, hey, take half, half, half. Midpoint, right? Definition of a midpoint. All right, so go with me a little slow now. Ready? Halves of, what do you know about these two? Halves of equal quantities are, okay, that's where this all comes from. That's how we're getting AE equal to FC. And I believe it's going to come up this weekend as well again. Halves of equal quantities are equal. That's a tough one. I know we haven't used it in a month or two, so maybe more. Okay, now hopefully that clears things up. And what is the method going to be now to prove these triangles congruent? 12? Side angle side. Questions? All right, so we're going to go back here. I want discussions galore here. It should not be dead silent in here. Discussions galore on how to do number 3. If you think you have it, oh, you're calling me over here. We may have a winner here. All right, if you are stuck, like I need one more pair of angles or sides, call me over. I'll help you out. All right, let's go here. Let's go. You can do it.